This was the last thing that we did. The next part is angular SHM. So till now, what you have seen, right? The particles are oscillating in a line, right? The spring block or the pistons or whatever we have taken, they're always going in a line. So we actually call them linear SHM. So in angular SHM, the restoring torque is proportional to angular displacement. Basically, force becomes torque and displacement becomes angular displacement. So others, do keep your cams on. So torque is proportional to minus theta. Negative indicates restoring force. The proportionality constant is minus k theta. Torque is I alpha. So alpha is minus k by I theta. So if you write this mathematically, this is nothing but d square theta by dt square is equal to minus omega square theta. This is what I was saying. Max doesn't care what you call. You can call it theta, x, anything you want. Max will simply say you change the variable. So for this function, we know the solution is theta naught into sine omega t plus phi. So so this thing has quite a resemblance if you see. A is proportional to minus x. Then you said A is equal to minus omega square x. And this we wrote as d square x by dt square. And then we wrote x is equal to a sine omega t plus phi. So here theta is the angular displacement. Theta naught is the maximum. So this is your general equation here. Theta is equal to theta naught. Theta naught is angular amplitude, the maximum angle from the mean position. Remaining all the symbols mean the same thing. This is not tough, but you have to be just careful because the symbols, right, they actually match up a lot. If I differentiate this, we end up with angular velocity. I won't write omega because we're already using omega inside, which is d theta by dt. That becomes theta naught omega cos omega t plus phi. So this term here is your maximum angular velocity. That is the only issue with this thing. The symbols, right, are messed up. If I write omega is theta naught omega, it gets confusing. Similarly, we can write angular acceleration alpha is minus theta naught omega square sine omega t plus phi. This is your maximum angular acceleration. You can see the resemblance. They all look the same. A omega square, A omega. Check it out. So the equations wise, what we did in the beginning, right? They all are valid. they ask you a question based on this, just convert this into x and solve it. That will be more simpler. So mathematically, there is no difference except you are replacing x with theta, a with alpha, f with torque. You understood the symbols. Do have a look at this page. Now, on this thing, right, primarily we have two cases. One is just simple pendulum. Can I turn the page? Have a look at this. So how is everyone celebrating Good Friday? No holiday, so no celebration. Then the other offline batch, someone was like, "Sir, we want holiday on Black Monday also." I said, "What is Black Monday?" I said, "Idiot, Black Monday is supposed to be some online sale or something. There's something called Black Friday, no? There's some sale in US or something. You get things for cheap." So this guy didn't understand the meaning between Good Friday and Black Friday. मतलब situation इतना खराब है. Next thing, simple pendulum. The idea is the same. What are the steps? Put the system in equilibrium, displace there from a small angle theta, find the restoring torque. So we have a pendulum here. This is theta. Here we are taking theta is small. When you say theta is small, we are assuming theta to be less than 5 degrees. Since theta is small, you can approximate sine theta to be theta. Length of the pendulum is L, mass is M. This point is your mean position. So the torques acting will be mg sine theta. That is responsible for the thing. So we have torque is equal to mg L sine theta. Torque is equal to minus I alpha. Remember, we always assume alpha in the direction of theta. If you took theta to the left side, we also take alpha to the left side. That's the convention. We always take acceleration in the direction of displacement. This is mgl sine theta. So for particles, moment of inertia is ml square. This alpha will be minus g by l sine theta. So technically speaking, this is actually an oscillatory motion. Alpha depends on theta, but it's not a linear function. Now for small angles, this guy becomes alpha is equal to minus g by l theta. So we can approximate for small theta, this becomes SHM. This is omega square. So the time period for a simple pendulum, the formula is 2 pi root over L by G, where L is the length from the point of suspension. There are variations on this, we will be seeing later on. Center of mass of the bob. Have a look at this. Clear? Next thing. What if it's not a particle, but it is like a a solid body there? A physical pendulum. So if you take some random shape here and if you hinge it here, let's say this is your center of mass. This is mg. This distance is d. This is theta. This would be mg sine theta. Idea is the same. So basically, this is the idea. Whenever they give you a system and ask you angular, this thing time period, displaced by theta, find the torque equal to I alpha, you'll get the relation there. The torque here is mg sine theta, the restoring force into this d here, minus I alpha, mgd sine theta. So alpha is equal to minus mgd by I theta. Again, this is for small theta. This is your omega square ka term. The time period is given by 2 pi root over the moment of inertia about the hinge by mgd, where d is the distance between the hinge and the center of mass. Have a look at this. These are the two standard formulas which you need to remember.
So they will give us the moment of inertia, right? Because
Why will they give you? Don't you know how to calculate?
yeah, but like, what if it's a shape like what will do?
Best thing now, we can ask them to give the answer, right? Meaning, let's say there is a question like there and options are there. Here we'll put a small scratch mark thing, scratch card. So when you don't know the answer, we can scratch this and we'll find an answer and we'll mark it. Oh, best है ना? इतना hard work क्यों करने? बस calculate won't finish it. I don't understand why they do such things actually. Poor kids, unnecessarily to trouble you all. We will put a petition in Instagram में करते हैं. We are famous in that only. तो. We want options, you go answers on the side. So it's like if you can do it on your own, you get 4 marks. But if you use this scratch card thing, this scratch card option, you'll get only 2 marks. So like that, we can do something like that. They'll give you some shape, right? Something like which you know only. Why will they give something weird? They give you something weird, they give you some equation or something to figure it out. You guys talk as if you are new to the class. Why are you talking like juniors? हो गया अभी आपका time. Now you all are seniors. 12th standard. You have to be very mature. Let's see a question. Your juniors are coming from next week. For the first 1 month, they will feel like, oh, Jay, हम crack कर लेंगे. We will see, we will show and all. It takes them, 1 month to bring them down from the throne to the ground. 1 month में नहीं लगेगा. I think first week में I'll bring them down. Let's see. Yeah, 150 already, 300 out of scratch card. And problem देखो ना, उसमें भी people will do -1 comma. इतना करने के बाद भी people will still do go for 1 comma. Just imagine, 2018 में around 10 or 12 lakh people gave the exam. People who got 0 out of 300, उसका rank था 8 lakh. मतलब सोचो, if you just shut your mouth and give an empty paper and come, you would be better than 4 lakh people. People do things, We think people are logical, but they're not. One of the biggest misconceptions when we are in IIT, we think people, right, when you talk to them logically, it will make sense, so they will follow. Nah. You just go to a person and say, you're looking so fat, why don't you diet something? Truth, right? They get offended. They think like you're a very bad and evil person. That is the reason we can't call a blind person blind anymore. He gets offended. You should call them visually handicapped. Okay? It gives you a very nice word to it. Visually handy. Arey, it's the blind hai na, to ho gaya na, discussion closed. So let's see. So we have a pendulum here. Mass m, length L. You kept a nail here at a distance of L by 2 from the top. So you displaced it by small theta. Theta is small. Release from rest. Can you visualize how will the motion be? This guy will start going like this. Then the string will hit this nail. And it will become like this. So after hitting the nail, only that part of the string will oscillate. So the pendulum hits the nail and oscillates about it. So let's call this angle alpha. This is also at the other extreme position. So find time period and alpha. Basically, alpha is the amplitude on the right hand side, theta is the amplitude on the left hand side. So you're releasing from theta, it will go to alpha on the other side. So what is that alpha? Is the question, the diagram clear, everyone? You placed a nail at the middle, L by 2 from the top. So this guy won't go with the proper oscillation. The top part will get stuck and the thing will oscillate. And then while coming back again, the full thing will come out. Huh? Full thing will come out. Let's get this. There, I just taught you one formula for simple pendulum, 2 pi rotor L by G. Now you need to play about that. Try. Now you guys are still fine, right? Our medical batches have become more hopeless actually. I gave them an assignment of 100 questions and I gave a paper of 25 questions from that paper. People still couldn't score, 120 out of 180. And the best part, you know what? They didn't even realize it is from the assignment. They had like, sir, paper was so tough, paper was so tough. I said, oh, paper was so tough, oh, poor kids. Then I showed them the assignment. Then I opened the assignment and said, did you see the second question? Oh, poor kids. I said, yes, sir. Did you see the first question in this? Yes, sir. Okay. I showed them all the 25 questions from the paper assignment. Now I said, oh, poor kids, the paper was so tough. What will you do? Oh, poor lambs. These people are going to become doctors and treat you guys tomorrow. He will go for some liver surgery. They'll remove the kidney and say, oh, shit, we forgot. ये क्लेवर नहीं है क्या? Oh, this thing looks like kidney रे, मैंने सोचा liver है. And they forgot. पता नहीं मेडिकल वाले करेंगे क्या? And you know how many people are writing medical this year? Any idea? 28 lakh. The number of people who are registered this year for this NEET exam is 28 lakhs. Next 10 years, every apartment will have one doctor. And your seniors का dates आ गया अभी 4th April से start हो रहे हैं उनका round 2. Answers, anyone? Easy, na? Why I guess, buddy, so much when you are going on the left hand side of the motion here. Now see, for the left part of the motion, what is the time period here? This time period will be T1, which is 2 pi root over L by G. For the right side of the motion, the time period is T2, which is 2 pi root over L by 2. Agreed? And when you're oscillating here, you're actually doing half of this red one and half of the green one. So the total time period will be T1 by 2 plus T2 by 2. बस इतना ही करना था. This is a very good main level question, right? Not tough, but yeah, should know. So half of that and half of this. Theta नहीं आएगा, God. Time periods never depend on theta. Forgot क्या? How to find alpha? That is a decent one. Cos inverse 4L. Without theta, how did you get Anika answer? Theta root 2, नहीं God. इतना अच्छा आंसर नहीं आएगा. I'm sure you guys are goofing up some part. Can you tell me, like, if you want to find alpha, there is something which you should know. Without that, you can't start the problem. Can I say like this? This and this will be at the same height.
How would
Why?
you know?
How would you know? Good question. यहाँ पे velocity कितना था? Left side में 0. Right side में velocity कितना था? 0. So potential energy should be same. They both should be at the same height, isn't it? Meaning, for people who are confused, let me draw that again. So initially you're starting from here. You keep the nail here. Anywhere you keep the nail, I don't care. When it comes here, think of like this. If this was your ground level, this height h and this height also has to be h. Do you agree? Because here the velocity is 0, here the velocity is 0. Total energy is conserved, so kinetic energy plus potential energy is constant. If kinetic energy is 0, then potential energy must be same. When you stop on the right side, you will be at the same height. That is a catch in the question. Without that, you won't get an answer if you don't figure out that part. That's what makes this question good. And this is alpha here. So this length will be, this is L by 2. So this length here will be L by 2 cos alpha. I'll write here better. And remember the total length is L by 2. So this length is also L by 2. And from the left hand side, if you see, this total length is L cos theta. So L cos theta on the left hand side should be equal to L by 2 plus L by 2 cos alpha. L will cancel. We get 2 cos theta minus 1 is cos alpha. That's your answer. Check. If you have not figured out that both will be at the same height, you can't solve the problem. You don't have enough data. Just imagine if you take some random height like this, how will you even compare them actually? But is that logic clear? Why the heights are equal? If I just ask you the heights now, that itself would be a pretty good mains level question. They'll simply ask you like this in the exam. They will say pendulum is there. It is released from height h1. They will say there is a nail here. After hitting the nail, it has come here. This height is h2. Which is greater? h1 greater than h2, h1 less than h2, h1 equal to h2. It's a pretty good theoretical question. Meaning everyone will think it's a pendulum question, but there is no meaning of pendulum there. It's all energy conservation. Please have a look at this. Ask me if you're confused. And there again, I just used one formula, 2 pi root L by G.
So like if the string had mass, it would lose energy, right? Like on hitting the nail.
Generally, we take a smooth nail, right? So friction का discussion ही नहीं है.
Achha.
Even if you have mass, it won't matter, na? The whole game is about, are there any dissipative forces? So generally, we take a smooth nail and all. If you say there is some friction and all, then definitely H2 will be smaller. That much we can say. Clear with this, everyone? Got this? Let's do a little deadlier one.
Sir, in the previous question, just wanted to ask, like the जो nail है वो directly जहाँ पे hinged है ऊपर जो भी support है
Yeah.
उसके directly नीचे, but if it was anywhere towards like the left of that,
यहाँ पे डालना है,
हाँ, तो
ठीक है।
that
अभी भी हाइट तो सेम रहेगा, हाइट has nothing to do with your nail.
fine.
What I'm simply saying is what initial kinetic energy plus potential energy is final kinetic energy is final potential. इस स्टेटमेंट में नेल का डिस्कशन ही नहीं आ रहा है।
No, I was just trying to visualize it practically.
नहीं, अगर नेल है ना, that would be a very good question if I ask you for time period. उसमें क्या हो जाएगा then? It is not a, यहाँ पे ना, the reason it become this easy is because these are half oscillations ना, T/4 था.
हाँ.
If you had kept the nail somewhere here, you have to find the time period for this part of the motion. Then mathematically it will become more complex. But the heights won't matter. Got it, no? So we have a pendulum here, length L. We have a pendulum here, length L, mass M, mass M. You connected a spring now. I know you guys are missing on springs, right? That is there. Second part, this is even more deadly. Our favorite rubber band. So we have this thing, and we have a elastic thread, spring constant K. Same data, length L, mass M, mass M. So both the pendulums are pulled apart and released. Means you're catching both of them and pulling them left and right. Both pendulums are pulled apart slightly. So it is not too much also, meaning small thetas. This would be a pretty good advanced paragraph question so they can ask. Find time period. Meaning, just to show you the diagram, this pendulum will be like this pendulum will be like this, the spring would become like this. So this is theta and this is theta, like this you did. So you displaced it this way and you displaced it this way and you left it now. Able to visualize the diagram? Theta is small. Remember, the steps are always the same. Bring the system in equilibrium, displaced by theta, find the restoring force, find the restoring torque, torque is equal to I alpha. That story is always there. So these question 34, right? You can't use a standard formula. Is the question clear? How do we do this? I'll give you 2 minutes for the first part. If you got the first part, second part will come. Without first, second won't come. Both are related. See whether you draw the FBD or not. What is the elongation in the spring? If you take this is theta, this is L. And this part here is L theta. So the elongation in the spring X will be 2 times L theta because got it. So when you displace by theta, elongation is L theta. What are the forces? We have mg sine theta and we have the spring force K into 2L theta. Theta is small. This much you should have got. If you got till here, you're on the right track. Try, I'll give you a minute more. Okay, I showed you the main thing. Now you just have to find the torque about the topmost point. Torque is equal to I alpha. aa jayega sab. mg plus 2kl. कुछ तो मिसिंग है आदित्य. डायमेंशन मैच नहीं हो रहा है. नहीं Anika, yours is wrong. Aditya, your dimensions are messed up. G by L2. Yeah, it might be. I don't know the answer exactly, but let's see the torque. So torque will be mg sine theta into L plus 2k L theta into perpendicular distance will be L cos theta is equal to minus I alpha. Now remember, theta is small. If theta is small, sine theta becomes theta and cos theta becomes 1. So this will be mgl theta plus 2kl square theta is equal to minus ml square alpha. This guy would be mg plus 2kl by ml theta into minus 1. That's your omega square. 2 pi root over ml by mg plus 2kl. You just messed up that ml ka part, I guess, Aditya. Easy? That once you got the FBD, it was nothing there. The problem only just looks a little scary. Question is not over. What if there's a rubber band? How will that mess up the question? What is the catch for the second one? We discussed this multiple times with the rubber band.
When it gets slack, then it won't matter.
It won't matter. So
So I think this time period plus 2 pi root Lyg divided by 2.
plus nahi aayega. See, you'll take half of this and half of normal.
हाँ सर, तो ये plus that divided by 2.
Like yeah. So when you're going like this, the rubber band is fine. But when these two guys come together, the rubber band becomes slack. So elastic cord is loose or slack for half of the oscillation. Therefore, the time period will be half of 2 pi root over this guy ml by mg plus 2kl plus the regular oscillation 2 pi root over L by G. Half of each. Make sense? So only when both of them go away from the mean position, the elastic cord will stretch and it will pull. So it'll act like a spring. But the moment they come closer, it just gets loose and it is massless, so it won't matter. So when stretched, elastic cord is similar to a spring. Clear with this?
Sir,
Aditya.
in the previous part, the restoring force is along the spring, right?
That's why I wrote na K12 theta. But
Oh,
this pendulum will go here, na, God. We're taking restoring torque.
okay.
You're not taking restoring force. Because if you try to take force, problem kya hoga pata hai? This thing ka acceleration is this way. Then if you take force also in this direction, then clear, na? Next one. Here we have a wall. E is equal to 1 and this angle is beta. Mass m, length L. This angle is alpha released from rest. And alpha is greater than beta. Alpha is small. Find time period for small oscillations. This is just like that spring problem, remember, with a wall in the front of it. So this guy will come here, hit the wall and bounce off. So this won't do a complete oscillation. Find the time period for the oscillations. Any answers? Right, Arjun. So this thing now, for simplicity, let's convert like this. X is equal to 0. X is equal to minus alpha. This is X is equal to alpha. But for some reason, you kept the wall here only, which is X is equal to beta. So from here to here, the time taken is t by 4. Let this be small t So what is small t? We know x is equal to a sine omega t. I'm just converting everything into x. So here x becomes beta, a becomes alpha, that is sine omega t. So time will be 1 by omega sine inverse beta by alpha. Therefore, the time period will be t by 2 plus 2 small t. So this is pi root over L by G plus 2 omega is also again L by G sine inverse beta by alpha. Make sense? Just make it like a linear, because mathematics doesn't care whether you're talking about an angle or a linear displacement. Since you're already comfortable with linear, you can just use that and finish it off. Is this making sense? I found the time from 0 to beta, that is small t. And what is omega here? Omega is root g by L. 2 pi by capital T. Easy? This is exactly the same problem which we did, but there I gave some good numbers like, a by 2 and all. Next thing. Next one. Any doubts? Vartika, clear now? Swastika, Maurika, got this? Aryan, Ali? Perfect. Next thing. We have a rod here. Mass M. This is a hinge here. You connected a string here of height h exactly in the center. This is length L. This is length L. So this is a massless rod with mass M attached at the end. And the other end is hinged. Okay. Now, if you actually think about this, how this goes, if you disturb this, right? This guy is kind of oscillating like this. Here, this mass M now goes in and out of the plane. It can't oscillate in the same plane. You're getting? It can't oscillate in the same plane. Think of like this. See, if you can see my hand on the screen, right? It is like this. Now, it's like when you oscillate this, you're getting, it is like this. You're getting it? So, because the length of the hand is constant, what happens when I try to pull it back, it goes actually this way. You're getting? It won't go exactly like this. It will be going this way. It comes little to the back and it goes like this. So the motion is kind of like this. So it is like a U shape, which is backward. It's not front like this, it is backward. समझ में आ रहा है motion कैसा है? You can try like this, you can take your hand like this, and if you can put your collar, this is like the string. And this is how it is going. Is that making sense? So this is little weird to visualize, but there is a way to solve these kind of questions. Let's try. So this mass M actually goes in and out of the plane. The rod is massless. So find time period for small oscillations. Think for a minute. I'll show you a method. You should have seen this kind of model once. Let's see. So these kind of questions, right? The problem is finding torque and all that stuff looks confusing, but if you actually observe that particle there, it kind of behaves like a pendulum. How is that? See. This is what we do. So whenever you have problems like this, step one, find 2 points on the system which do not move. So if you see that here, this guy is 1 point here and this guy is 1 point here. Second, then join them and drop a perpendicular from the mass. Let's call this point D. This point is B. Now, if you observe this, doesn't this look like, if I just rotate this a bit, it kind of looks like point A, point B, point D, with 3 points are stationary. And we have one pendulum here of mass M, which is just oscillating. Let's call this point C. So we observe here the pendulum behaves as if it is oscillating. So if it is a simple pendulum, oscillating about point D. Does that make sense? Now, if I just don't show you the rod and everything, it looks like that only. Meaning whatever is this oscillation, the rod also would have done the same thing. And like I keep saying, if the situation looks similar, it doesn't matter. Max doesn't care. So now what is the time period then? First, everyone should agree with this page. This is how you solve if you have a problems like this. I'll show you 1 or 2 more models on this. So this is what we do next. So if you extend this, remember this is mg, this is theta. So the pendulum will think the gravity has become g cos theta, isn't it? If you're saying CD is the pendulum, then you should take acceleration also along CD. So the time period will be 2 pi root over L by G, where L length is CD and G is component along CD. Everything should be along CD. So because now, basically you're treating your CD as your vertical line now. And from the geometry, this is L, this is L. If that is theta, 90, this is 90 minus theta. This is theta. So we get tan theta is equal to H by L. And tan theta is also tan theta, I know sin theta. Sin theta is CD by 12. Opposite by hypotenuse. So that's your length CD. Yeah. So this is 2 pi root over 12 sine theta by acceleration g cos theta, which is 2L by g tan theta. Tan theta is h by L, which is root over 2h by g. Check your answer.
So normally forces say we can't do it because we don't know the hinge force, right?
Hinge forces pata nahi hai, wo it is going in and out of the plane. It becomes very difficult to visualize. End of the day, the whole thing behaves. Dekho na, if you're saying this point is fixed, this point is fixed, this point is fixed, doesn't this just look like a plate here? Where this point is behaving like a wall now, and this one point is simply oscillating like a pendulum. Making sense? So basically, that's what I was saying. This thing will just look like this. ABD is a wall, and this is like a pendulum. Clear? So this is how you do handle these kind of questions. Let me show you one more like this. So whenever a particle, see, one thing I'll tell you, a simple pendulum, right? If I have one string tied to one point and one bob, that is very easy to make. 2 pi root over L by G, your life is done. The problem comes whenever you're trying to connect to multiple points, it becomes an issue. That is how you should know that we have to use something like this. The plate is flipping for the pendulum to oscillate. Yeah, same thing. You can see the plate is oscillating, which is as good as saying the line CD is oscillating. Clear? Next thing. We have two walls here. This is point A, this is point B, this is mass M, this is L1, this is L2, this is 90, this is length A, this is length B. Gravity is there. Fun time period for small oscillations. So this is the hint in this kind of questions, that the pendulum is connected to two different points. The moment you see this, the general formula is not applicable. Then, this is the method we have to use. Find 2 points which are not moving. Luckily, you'll always find those two. Join them, drop a perpendicular, finish it off. Try. You got 2 minutes. And again, if you observe, we're just playing with that simple pendulum models only. I didn't bring plates and all that nonsense into picture yet. Today we'll just stick to the angular SSM part. Next class we'll wrap up the chapter. There is a little geometry though, but I hope did you figure out the diagram? I don't think calculations are not that great, but you can manage. So step 1, you need a line which is fixed. That is your AB here. These are the 2 points which are not moving. A, B. From here, drop a perpendicular. Let's call this guy C. Let's call this guy D. So time period is 2 pi root over length along CD by gravity along CD. So if I take this angle is alpha, this angle is alpha. So this component is G cos alpha. If you take this angle is theta 1, which I can find, this angle is theta 2, that also I can find. AB is nothing but root over A square plus B square. I know all the sides of the triangle. So theta 1, theta 2, I will get. This angle will be 90 minus theta 1. So CD I can find. Sin theta 1 is CD by L1. वो आ जाएगा. And cos theta 1 is nothing but L1 square plus AB square minus L2 square cosine rule. 2 times L1 into AB. So theta 1 भी आ गया. I just need to find alpha. How to find alpha? This total angle is 90 minus theta 2. Wait, now why do I bring theta to actually? This will be 90 minus theta 1. Any ideas how to get alpha? Areas. Areas से कुछ नहीं होगा. This is 90 minus theta. This whole thing is theta. This will be theta minus alpha. I know CD. Numbers are given, that would have been easy. There. We will find alpha. How we will find that you guys will figure out. We are all max experts. So once we get alpha, job's done. Put it there, you'll get the answer. This guy will be 2 pi root over that length CD that I found, and this will be g cos alpha. Get cos alpha from somehow. Let me know how you got it.
So why do you need alpha?
है वो g cos alpha कैसा आएगा God?
It's like it's a small angle. So you just write it as one.
Come again?
No, like it's cos alpha मतलब small angle approximations. So
अरे
just write it
God,
as
you
one.
are getting confused. वो cos alpha क्या था? That is displacement ना. This angle of displacement is small. That is not this. You're getting it? This is the pendulum na. When you displace this displacement angle is small.
Huh.
This is some other alpha you're talking about. It has no relation to that.
Okay.
समझ में आ रहा है? Why will this alpha be small, Ray? You're treating, this is your pendulum na, CD. So when you displace this, it will displace like this na. So this angle is small na. This will be
Yeah.
out of the plane, isn't it? This will be
Yeah.
out of the plane.
But I mean, okay, fine, sir. Okay, got it.
Alright, na, this alpha is nothing to do. You're not oscillating in the direction of alpha na. Clear with this thing? I don't know how to calculate alpha. I'm not able to figure out right now. The geometry, check it out. So physics part is done. Max part, you need to check it out. Someone got L1, L2 by 2 is CD root A2. But why are you equating areas, right? Why should this area of triangle and this area should be equal? They have no relation to each other. That is AB, this is L1, L2. There are too many variables. That's why it's looking difficult. If numbers are given, maybe you would have got this thing. I have some ideas, but it's becoming more complex actually. This length, I can use sine rule from here. Sine 90 minus theta by this, and this angle by this. Then I'll get this angle here. And from this triangle, again, I can do this. But geometrically, it is just becoming more complex.
So and then you get it in inverse, not alpha.
भाई वो सब आएगा. Numbers are given, to have been easy. But everyone got the process, right? How to handle this kind of problems.
Yes.
That is important for me. Cos alpha, you guys are max experts. You'll figure it out. I'm bad in max. Next thing. So we have a rod here hinged. Find time period for small oscillations. The same rod is hinged somewhere here. This is center of mass. This is X. find x for minimum time period. So where should I hinge the rod so that I get minimum time period? Someone got it. Okay, the angle, let's see. You're saying what? Cos theta minus alpha, okay, should be cos 90 minus theta plus alpha. हो सकता है, because this is 90 minus alpha. This is 90 plus alpha, okay. So using that geometry, theta minus alpha, I'm sure I'll prove 1 is equal to 1 or something. Alpha will cancel, 90 will cancel. I proved theta is equal to minus theta. I got theta 0, wow. I did something else. Total should be 180 now. 90 minus theta is 180. Alpha will cancel, 90 will cancel. Yes, I proved theta is equal to theta and 1 is equal to 1. Hence proved. I'm a mathematical genius. So that is of no use. I don't know how you got that though, but let's get this. We have a rod suspended from one end, and second question, you suspend it at a distance x. Find x for minimum time period. Which formula to use? Physical pendulum. This guy. 2 pi root over I by mgd. I is the moment of inertia about the hinge, and d is the distance from the center of mass to the hinge. Let's get this. Try. Easy one. Just a formula substitution, the first one. Zero. You know the meaning of zero, God? You're keeping in the center. Means you know what you're doing. No matter how much you disturb, it won't oscillate only. It'll be at the same position. You got infinity. I'm asking for minimum time period. You found maximum. First was easy. Time period is 2 pi root over I by mgd. 2 pi I is ml square by 12. mg d is L by 2. 2 pi root over L by 60. Right, Lakshika, you got that right. Right, Swastika. Hadi, wrong रे God. L by 2 अभी मतलब क्या है? The topmost position. What are you finding exactly? क्या कर रहे हो? I got your problem. Switch on your light in the room. That is the reason you're not able to get the answers right. Switch on the lights. You need light. See, once you switch on the light, you'll get right answers. Second one, answer everyone. Try. I'll give another 30-40 seconds. You have to differentiate maximum minimum. Let's see. So for this guy, the time period would be 2 pi root over I. I will be I center of mass plus parallax's theorem. Mx square by mgx. Just 2 pi root over ml square by 12 plus mx square by mgx. This guy would be L square by 12gx plus x by g. So I need to maximize this function here. So d by dx of L square by 12gx plus x by g is L square by 12g minus 1 by x square plus 1 by g is 0. We get x is equal to plus or minus L by root 12. Actually, both will give minimum. You can have L by root 12 on either side. Clear? So they can ask you an interesting question. Plot the time period versus x graph. If I ask you to plot time period versus x, at 0, you will have some, at 0, right, the graph will go to infinity. Then it will reach minima, and then again it would increase, and the graph will stop at L by 2 because there's no length after that. It will be symmetrical on both the sides. This would blow off to infinity. Because exactly if you keep in the center, you won't get any time period there. This guy is L by root 12 minus L by root 12. This is what I keep saying, people, during Rangoli, you want to do some painting. Physics ka graphs are the best. You don't have any new interesting ideas. Just take 3-4 functions and start drawing. Getting how the graph looks? As you get, if you put it exactly in the center, you get an infinite time period. It won't oscillate only. Every position is equilibrium. Simple reason, dekho na. If you hinge it in the center, where is the force, mg? Where is it passing through? Center. So what is the torque? 0. There's no restoring force. So every position is equilibrium position. It's actually called neutral equilibrium, if you remember. It's not stable, it's not unstable, it is neutral equilibrium. Hinging in the center. Clear with this?
If you place it below, what will be the restoring force?
Kuch nahi hoga, God. Then this will just fall down, na. Then this is an equilibrium position will be what? The rod will become like this, na, again.
Then we should discard the minus wala thing, no?
Why? How do you find time period? Bring it to equilibrium position, then disturb.
So you're going to make it fall all the way down and then...
Yeah, then you do the problem.
ठीक है.
Always. That's how you do.
So,
Okay? God.
in the first question, A वाले में
Uh-huh.
ml square by 3 होता है ना?
I was just testing you all. No one found out the mistake.
That's what I was also thinking.
Nah, kuch nahi thinking. I was trying to test you guys, and you all none of you could figure out the mistake.
Because if I would have said, you would have said God, and then this thing.
God क्या होता है? You should have said it,
I
na.
was so scared to.
Scared क्यों है रे? Even I can do mistakes. But this was a test for all of you actually. Esha with her keen eyes figured out like an eagle catching a mouse. Next one. ML square by 3 था. Just remember the I about a hinge I cooked up. You guys get scared of me, क्या?
Yes, so very scared.
I don't even say anything, right? I sometimes feel like I'm like an innocent physics teacher, no? Next thing.
Parent teacher meeting.
हाँ, you guys do nonsense that I shout, but ठीक है. But do ask na, even I can do a mistake. Maximum what will happen? I'll just call you God. What else? I just call you God also. I don't even call you something with weird name. Yeah, people get scared of getting called gods. क्या बोले? Next one. We have a hollow shell. Filled with liquid. At the bottom, there is a hole. Liquid leaks at a constant rate. So how does the time period vary? And you just disturbed it. So options will be, it will always increase, it will always decrease, it will increase and decrease, it will decrease and increase. ऐसे 4 options होगा. How does time period vary? Easy one. This came in the exam. Always increase, always decrease, increase and decrease, decrease and increase. 4 options. Or remain same. वो भी है. Now, most people think like, sir, mass is changing. How does that affect the problem? What we are forgetting is, initially when the liquid is like this, as the liquid is coming down, when it is completely empty, initially the center of mass is here. Center of mass goes down a bit. Then center of mass goes down a little more. Then the center of mass actually starts coming up, and finally the center of mass comes up. So if you look at the motion of the center of mass, it goes down and comes back again. So COM goes down and comes up. As it is becoming empty, because at any point the center of mass of the system is center of mass of the liquid plus the shell. Center of mass goes down and comes up. And remember, what is LK definition? L is the distance between the point of suspension and center of mass. Therefore, L increases and decreases. L is not the length of the string. So here L is the distance between center of mass and the hinge. So therefore, time period increases and decreases. Easy?
Yeah.
Similar one. I hope everyone is clear with this. Clear, na Ali? Aryan? Palaksh?
So eventually it will come back to the original time period, right?
हाँ, because hollow shell को center mass तो वापस वहीं पे आएगा ना. Next one. We have a hollow shell. Mass M, radius R. This is length L, filled with non-viscous water. Mass M. ठीक है? Find the time period. Case 1, when it is water. When it is in liquid state. Case 2, when it is frozen to ice. You have freeze the whole thing and then inside became an ice ball. I hope you remember. ये कहाँ पे गया था हमने? Rotation में. Remember?
Rotate.
Ball rolling from the top. Get it? Please don't hesitate to point out any mistakes. Don't be scared for that. Max will call you God. I don't even call you guys, call you dragoons. I don't call you dragon. I don't call you cat, dog. Xena. अर्जुन को देख के तो लगता भी नहीं है he gets scared, but he says that way. Let's see. This year when we meet, we will see. What is the answer, everyone? You just need to find I का value.
Yeah, but like it's बड़ा लंबा ना like how will you type it out?
No, let it be. Check. See whether you got the same thing. So first case, when it is water, what will happen? Water does not rotate, no? So you just take it like a mass. One more thing, we will assume L is much greater than R. Or else you can't take the shell like a point mass. Then the moment of inertia I about that axis will be 2 by 3 mr square plus m into L plus R whole square. Because you have to take the distance from the center of mass. This was R and this was L. I could have taken L from center, but okay. This is for the shell. Plus the water will be simply m L plus R whole square. This is just behaves like a particle. When it is frozen to ice, now the moment of inertia will be 2 by 3 mr square plus m L plus R whole square plus 2 by 5 mr square plus small m L plus R whole square. So the only thing that will change is this one term here, the rotational component. And the time period will be 2 pi root over I of the system, which we have calculated, by total mass m plus m. G, d is the distance from the center of mass to that point, L plus R. Check. See whether it did the same thing. You cannot treat the shell plus water as solid sphere. Don't do that. You have to separate them as two different parts. You have to treat them as a solid sphere and hollow sphere separately. Clear? This model is important. The water won't rotate. We have seen this in rotation. This is the second time you're seeing again. Clear? Take a break. Come back with 7:10. Any doubts so far? Please ask.
Still in question 28. Let's go to that question.
28.
Yeah, it was last class covered. Like,
Uh,
yeah, you didn't need to give us both L square and A1, right? Like in the question. Like
which
the-
one? Both?
In the question, you gave us both L, the side of the cube, and the area of cross section. You only needed one of them.
You need one of them.
Okay, yeah, that's it.
You don't need actually because answer में हाँ वो cancel हो जाएगा ना anyway.
हाँ. And
But
so,
and end में I wanted to show with A1 and A2, so
and so in that other one, that theta1, theta2 one, that you. So इसमें basically you just can like balance the forces, right? The liquid column on the left and whatever's the excess that you took, right?
this part tak there is no problem, no? They'll balance each other. The problem is this guy.
Yeah, got it.
That's why yeah, that restoring force is accelerating the entire liquid.
Yeah, understood. Thank you.
Anyone else? Anything else in the notes? You can ask. Take a break. Come back with 7:10 then. Sure, let's start. So we have an half ring here, mass and radius r. It's hinged at the top. Find time period for small oscillations. I told you this will come again in rotation. Yeah. First thing, how to do this thing. Time period is 2 pi root over IA by mgd. Let's call this point A. This would be the center of mass. This is your center C. We know IO, and this distance is 2r by pi. And this is r minus 2r by pi. So IO is I center of mass plus m into IA will be I center of mass plus m into r minus 2r by pi whole square. Subtract them. So here we get IA is IO. IO is nothing but mr square. We get this thing. And what is D here? D is the distance from the center of mass, r minus 2r by pi. Therefore, if you substitute here, you end up with 2 pi root over 2r by g. Check it out. We have done the exact same thing in rotational mechanics. So we have to use parallax theorem. The most common mistake, right? What people do, they take IO and from there directly they use the parallax theorem. Did you guys do that? Hope you didn't do that. Again, if you did that, MR square, you get 2 MR square, and you took MGR, you would have still got the same answer, I guess. If you had done that, you would have still got the same answer, I guess. Operation failed, but patient survived. Yeah. Check it out. Clear this in case you forgot. Here. Question 22. Half ring. All got this thing. Next one. We have a rod here. This is hinged. We have a spring here, K1. We have another spring here, K2. This is a rod of mass M, length L. This distance is L by 2. So this second spring is exactly in the middle. Now the rod is gently pushed. The rod is slightly disturbed. Find time period for small oscillations. Meaning this is what they did. They compress the rod like this. So kya ho gaya? The spring will compress, the spring will elongate. So they will pull the rod back to the natural state. So this will start oscillating. Find time period for small oscillations. See, displace this by theta, small theta. This guy will be L by 2 theta, and this guy would be L theta. So if you try to draw the restoring forces, this will be K1 L by 2 theta. Remember, we are writing only the change in torques. mg we are not including because mg ka torque does not change much. Initial also mg ka torque is there now. The mg ka torque we don't consider because it is not changing. This would be K2 into L theta. We ignore mg since torque due to mg does not change. Because initially, what is the torque? mg L by 2. Now, what is the torque? Almost mg L by 2. The theta is anyway pretty small. So torque about the hinge will be K1 L by 2 theta into L by 2 plus K2 L theta into L. This will be minus ml square by 3 alpha. This is K1 by 2. This is your omega square. Check. That's your answer. Two things will happen. The compression is L by 2 theta, and when you take torque, again one more L by 2 will come. So it actually becomes K1 by 4. And mg you don't consider because what is initial torque mg? So that is, see, initially springs are already compressed. Huh? These are additional elongation or additional compression. This L theta by 2 is additional spring force. The initial spring force are also cancelling the mg ka torque. So you are considering only the torques which are changing. The spring ka torques will change, mg ka torque doesn't change. The initial spring forces will cancel mg ka torque, so we don't consider it. Clear? Have a look at this. Let's see one more like this. This L theta is the additional elongation. The spring is initially compressed already by some amount. I can say change in elongation. That is better word. Next thing. All got this? We have a rod here hinged. We have a spring here. Okay. We have a block here, mass m. This is a rod of mass m length L, same mass. This distance is L by 2. Find time period for small oscillations. Initially, system is in equilibrium. Here, be careful, huh? Here, mg ka torque changes. See, let's try to disturb this. Try. Here, mg also will come into the picture because see, initially, what is mg ka torque? 0. But when you displace the rod, now even mg is also rotating the rod, no? In this problem, mg you have to take. Try. I'll give you a minute more. It's a good one. Let's see. So this length will be L by 2 theta. So the spring force will be K into L by 2 theta, and this will be mg, and this will be tension. Tension is not equal to mg. Be careful. You'll see why. On this side, this block M. So this is the same tension T acting here, and this is acceleration. Here T is the change in tension. T is not the initial total tension. Because you push this thing by right, the tension is changed by T. Here we don't write mg for the block because this mg does not change. So we have T is equal to minus ma. Now, if you write a torque about the hinge, again, we always assume alpha in the direction of displacement. It will be T perpendicular distance L cos theta plus mg L by 2 sine theta plus minus K L by 2 theta into L by 2 theta cos theta. Theta is small. The torque due to the hinge will be minus ml square by 3 alpha. This is tension, so minus ma L mgl by 2 theta minus kl square. This is L by 2 cos theta by 4 theta. And remember here, at this point, acceleration, right? A is equal to L alpha because the string and the block are connected by the same string. Minus ml square by 3 alpha minus ma minus ml square. Yeah, this is plus only because we took in the same direction. There, that's your omega square. You can simplify it further. Tension is not equal to mg of the block. This T is the change in tension. When you pushed it, the tension has increased by T. So technically speaking, if you want to write now, this should be written as T plus dt. This is mg is equal to ma. So this T and this mg will cancel. So what you left is dt. So for the block, you don't write mg, but the rod you will write because initially when the rod is vertical, the mg is passing through the hinge, there is no torque. Like I said, you always write the change in forces and change in torques. When you displace by theta, the spring will generate a torque, the tension will generate torque. Now mg is also generating a torque. Do have a look at this. Another simpler way of doing, you know what? If you remember a torticization rotation, you can take this block and attach it here. Because they're connected with a string, you could have just made this problem. Take that block and just attach it here. That would have been easy, but the problem is iska bhi torque lena padega. Now that will be confusing. Please look at the steps here. The one common mistake that I see people doing is they write T is mg. This T is not constant. So in this we consider mg because initially torque due to mg is 0, but when displaced, it is not 0. So there is a change. If you see all these terms, right, are change in torques. This guy is the restoring torque. Clear? There is a very interesting thing about this answer. If you observe here, if this thing, right, KL by 4 is less than mg by 2 means what? Time becomes undefined. They can ask you that question also. Find the relation so that the system oscillates. If KL by 4 is minus mg by 2 is less than 0, time period is undefined. Basically, system is an unstable equilibrium, meaning the moment you displace this will never come back. It will just keep falling down. The mg is so strong, the spring can never stop it. It won't oscillate. It is an unstable equilibrium. There will be no oscillations.
So question can be maximum weight for which this is simple harmonic.
Yeah, they can ask you find K. Find K if the system is oscillating or motion is SHM. That would be a paragraph question. They'll ask you that find the time period and find the value of K for the system to oscillate. Solid cylinder, mass and radius r, with a spring connected in the center. This is rough. Friction is mu. There's no slipping. Means, you know, how will it oscillate? This will go like a wheel. It will rotate and come front. The motion will look like this, coming front and going back. Able to visualize how it is? This will roll and go front and roll and will come back. If the ground was smooth, you know what would have happened? If the ground was smooth, this will simply go left and right now. It will just go like a block left and right because there's no slipping. It will rotate front and rotate back. So find time period for small oscillations. Find time period and the maximum amplitude for the system to be in SHM. Let's get this. How do we do this? Should I show you one? See, go back to the basics. What is that? Displace the body by X. Write the forces. Kx. Let this be friction. Let this be acceleration. Let this be alpha. Take torque about the bottommost point. That's the most easiest one to do because there's no slipping. Torque about A will be Kx into R. Be careful, that is equal to minus I alpha because torque is this way, but you took alpha this way. Signs are important. Kx into R, and this is IA about alpha. This is a solid cylinder, so minus 3/2 mr square. Parallax is there. And you end up with A is equal to minus 2k/3m into x. Done. So time period is 2 pi root over 3m/2k. बस यही करना था. Displace by x and find the time period. It's a solid cylinder, right? Did you take solid sphere or what?
Yeah, that was
Clear? Question अभी तक हुआ नहीं. Find the maximum amplitude. How will you do that? Now from here we can find F minus kx is equal to mass into acceleration. So friction will be kx plus ma is minus 2kx by 3m. So friction will be kx by 3, which will be less than equal to mu mg. Therefore, the maximum displacement you can have is 3 mu mg by k. If you try to stretch the spring more than this, the friction will exceed the mu mg ka value and the body will start slipping. So this is your maximum amplitude. You cannot stretch the spring more than this. Easy? Everyone got the logic here? I'll give you one more like this. Now you try. This is how you handle the problem. Displace by x. Let the spring force be there. Find the torque about the bottommost point. It is not slipping. You will get the answer in one step. If they ask you amplitude, it becomes a pretty good question. Anyone not clear with the steps? Neil, clear with this? Udayan, got this? Vidyut? Perfect. Now you guys try a similar one. Solid sphere, but this time I keep a spring on the top, K1. I keep a spring in the middle, K2. There's no slipping. Now find the time period. Find time period for small oscillations. Idea is the same. Displace by x and find the restoring forces. By 2m by 15k. Anyone else got the same? Show you. Anika, you took both the springs same gear. See. Let's displace this by x. Now here, be careful. Huh? If you displace this by x, this will go by x and this will go by 2x. Hope you realize that. Because it is not slipping, on a sphere, the points are different velocities. If this point has velocity 0, this point has v, this point will have 2v. So the upper spring will stretch by 2x. Now, if you write the forces, this guy will be k1 into 2x This guy got compressed, so this also will push k2 into x, and I will take acceleration this way and alpha this way. Friction will be this way. Take torque about the bottommost point. K2x into r, 2k1x into 2r is equal to minus IA, that is 7 by 5 mr square alpha. This guy would be 5 by 7 m minus k2 plus 4k1 on r will cancel is equal to a into x. Check. That's your omega square, and you get the time period from there. Easy. The mistake, the most common mistake is this: people forget the 2x part. Both the springs will not stretch with the same amount. This is not, if it is a smooth surface, both would have been x. Clear? Let's see one more. I hope I don't got your mistake there. The 2x part. MR solid cylinder, K. This is a Planck, mass M. There is no slipping anywhere. Find time period for small oscillations. Try. Everyone focus. Don't sleep. Both the masses are same. 2 pi, there is a friction everywhere, God. If there's no friction, it will slip, na? 2 pi root 5m by 8k, 3m by 4k. Let's see whether you got the FBD right. See, let the cylinder move by x. Let the acceleration of the cylinder be a. You have to be very clear. When you say a is proportional to x, it should be the same a and the same x for the same body. So if I displace this guy by x, I will get the same acceleration a for this guy. Now, this point on the top will go with 2x. That means the spring at the back got actually moved by 2x, and the plank is accelerating with 2a because it is not slipping. Hope you have taken that into account. If the cylinder moves by a, the plank will go by 2a. Now, if you write the forces, the spring force will be k into 2x, friction, let's call it F1, and acceleration 2a. Now, on the cylinder, the same friction will be F1 piche, there will be F2 here. There are two frictions here. And remember, you defined this as acceleration a. Please check your FBDs. If you got till your question is over, actually. Now, if you take torque about this point here, torque about A will be simply F1 into 2R is equal to minus IA alpha. And from here, we can see F1 minus 2kx is equal to m into 2A. From here, I get F1 ka value. 2ma plus 2kx. Take this and dump it here. 2ma 2kx into r minus ia. It's a solid cylinder.
Should be 2R, right?
Parallax system 2r था वो. Hmm. 3 by 2 mr square alpha. A is equal to r alpha. This guy would be 4ma 4kx minus 3 by 2 ma. Bring all a's to one side. 4 to 8, 11 by 2. ma is minus 4kx. Minus 8kx by 11m. Therefore, the time period is 2 pi root over 11m by 8k. Anyone got this? See where you guys goofed up. There are multiple things you have to be careful. If you assume the cylinder is going by x, plank will go to x. The cylinder acceleration is a, plank acceleration is 2a. There are two frictions, F1 and F2. If you take torque over the bottommost point, F2 eliminates. That will make your life little easy. But still F1 though you can't eliminate. So check it out. The main thing is getting the FBD and the constraints properly. Clear, everyone? Try this as a homework problem. This is a good one. This is a solid sphere. Mass m, radius r. This is a hollow sphere. Mass M, radius R, spring constant is K. They're placed on a rough ground. There's no slipping. Both the spheres are pulled apart by A, means you stretch the spring by A basically, and released. Find the time period and the amplitude of each sphere. It's a good question, Ray. Take time, 15-20 minutes you can spend, try once or twice. You have time till next Wednesday. Do make sure to try this thing. This will really test your rotational mechanics and SHM. And for people who want to verify the answer, the time period will come to be 2 pi root over 35 m by 46k. That is the answer you should get. Definitely try this, spend some time. So next class, when we catch up first thing in the class, we'll be doing this. So do try. After this, we have few more problems on this thing, and then we will do something called torsional pendulum. That is easy, and we'll do infinite pendulums. And then we have something called, forgot the name, say. Damped oscillations. So damped oscillations is removed from the mains portion, but hey, bits mein hai thoda and advanced mein abhi tak hai. They didn't mention anything about it. So we will do the basics of it also, just in case. So mostly we should wrap up in the next class. Time might permit also. If time permits, then we'll start off with viscosity introduction. After this, we'll start off with properties of matter. That is done, right? Properties of matter
Yes,
going
sir.
on. So we'll finish our properties of matter after that. And then we will go for gravitation. So, okay, with this, we'll wrap up for the day. So do try this and come. We have already done 46 problems. So make sure to go through this. And especially today's class also, we did pretty good ones. So I'll see you guys again next week on Wednesday. And this week, a test is there till Saturday night, 11 o'clock. So do make sure to give. In case you have not given, I extended it by one more day. So, okay. So those who have any doubts, stay back and ask. Also free to leave. So take care, stay safe.